Hello class, this is Mr. Buford. We're about to look at factoring. This is a tutorial on factoring when a is equal to 1. And this is a review. You should have had an assignment on this and an exit ticket. But for those of you who would like just a little tutorial on this, just to sort of freshen up and clear your understanding on what we've done, I'm providing this sample. Okay, so here we have, remember with quadratic factoring, what we're trying to do is take a quadratic function, ax squared plus bx plus c, and break it up into two binomials, x plus g and x plus h. And we're looking at the condition where a equals 1. So that's why you don't see an a here. Otherwise you would have an a here. But we're looking at the condition, the simplified factoring situation where a is equal to 1. And so our goal is to, whatever quadratic function we have, we want to break it up in a quadratic function is a trinomial because it has three terms: the x squared term, the bx term, and the c term. We want to be able to break that trinomial up into two terms, into the product of two binomials. And a binomial is an expression that has two terms, x and g, x and h, while the quadratic function has three terms, x squared, bx plus c. So our goal is to break it up into two binomial expressions. When you multiply those binomials together, they will give you back this original function. In order to find these two binomials, we have to find g and h, and the criteria for finding gh is such that whatever the coefficient c is in our original quadratic function, g and h, the product of g and h will always equal c, and the sum of g and h will always equal b. And that's pretty much what we need to do, because our goal is to break this quadratic function up into two binomial expressions, such that when you multiply them together, they'll give you back this quadratic function. But to find these binomials, we need to find g and h. And again, the way that we find g and h is through this criteria. In our quadratic function, b is going to have a value and c is going to have a value. And whatever b and c are, we can get gh by looking at what c and b are. Again, c is always going to equal to the product of g and h, and b is always going to be equal to the sum of g and h. So let's look at this in a real world, or a real quadratic function where we have some numbers. Here we have the quadratic function x squared plus 11x plus 28 equals x plus g times x plus h. So we want to be able to find the g and h such that g times h equals 28 and g plus h equals 11. Okay, and so what we could do, we could come up with some factors of g and h. For example, since this is a small number, we don't necessarily have to go to the quadratic function spreadsheet. We can probably just come up with these in our head. 2 times 14 is equal to 28. That's a factor of 28. So 2 times 14 could be our g and h. But when we take 2 and 14 and add them together, we get 16. So even though 2 times 14 does equal 28. It doesn't satisfy both of our conditions here. We need a g and h, which when we multiply them together gives us 28, but also when we add them together it gives us 11. Let's try another factor. What about 4 and 7? 4 times 7 is 28, and 4 times 7 is equal to 11. So that satisfies both conditions here, and therefore that is our solution. So the 4 and 7 will represent the g and h that we need in our equation to factor this quadratic equation from x squared plus 11x plus 28 to x plus g and x plus h. If we substitute these values in, that x plus g becomes x plus 4, the x plus h becomes x plus 7, and that's what you see here. And so that's pretty much how we do it. Let's go down to the second example. Here we have x squared plus 15x plus 56 equals x plus g and x plus h. Again, we want to find the values of g and h so that g times h equals 56 and g plus h equals 15. So what two values, what two numbers, when you multiply them together gives you 56, and when you add them together gives you 15? Well, the way that we do this is find factors of 56. And again, we could start with 2 times 28. That's an easy one. 2 times 28 does equal 56. But if g and h are 2 and 28, when we add 2 and 28 together, we get 30, not 15. So that doesn't work. What about if we choose 7 and 8? We know that 7 times 8 from our factoring, our multiplication tables, 7 times 8 is equal to 56. And when we add 7 and 8, that gives us 15. So here we see that our g and h is 7 and 8. Okay, so we just put a 7 here for g and 8 for h, and we're done. Now, if, for example, you are not good at keeping numbers like that in your head, and you don't remember your multiplication tables, you could have went to the your quadratic function factoring worksheet, and we could have just put in our numbers for a, b, and c here. So we say 1, 15, and 56. Okay, so we're looking for a g and an h such that when you multiply them together you get 15. You get 56. When you add them together you get 15. So now that we put our numbers in here, we can see that the factors that we're looking for are 56, and you see that we have some numbers here already, but that's because we had used this previously. So what we want to do is come in here and just erase the yellow boxes. Remember, we only erase numbers in the yellow box. Anything in any other boxes, we don't want to touch them. So we're starting off fresh now, and again we want to pick a number that's the lowest possible number that would go into 56, and that would be 2. And you see here we have factors of 2 and 28. When you add those together it's 30. We want factors that when you add them together they're equal to 15. So here, try 2 again. That doesn't work. Try 2 here. And so you see here we have factors of 7, 8, and 7 that equal 15. we go back to our quadratic our quadratic function factoring tab, and if we try putting in 8 here, you see it gives us a solution of x plus 8, x plus 7. And again, we had already come up with that, but I just wanted to show you how you could use the quadratic function factoring worksheet to help you solve that if you didn't keep those multiplication type tables in your head. So that's basically how you do all of these problems. As the numbers get bigger, as you have seen in some of your homework problems, it's probably helpful to have something like the quadratic function worksheet there to help you with factoring, but in general, this is how you do these problems. So if you have any questions, please let me know, and we will be able to help you. Alright, thank you. Hope this helps, and look forward to working with you soon. Take care.